In this video here, we're going to take a look at L'Hopital's rule. Now we can use L'Hopital's rule to help us evaluate limits of some indeterminate forms. So L'Hopital's rule allows us to find a limit of a function that can be expressed as a quotient of functions. So in other words here, f of x over g of x, where f and g are both differentiable functions at points where f of x and g of x both tend to 0 or both tend to plus or minus infinity. So generally speaking here, it's often easier to evaluate a limit by using L'Hopital's rule rather than the Taylor series. So let's just explore then how to evaluate a limit by using L'Hopital's rule. Now there are some conditions required here for L'Hopital's rule. So L'Hopital's rule states that for two functions f of x and g of x, if either... So for the first condition here then, the limit of f of x as x tends to a must be equal to the limit of g of x as x tends to a must be equal to 0. That's my first condition here. Or the second condition is that the limit of f of x as x tends to a is equal to the limit of g of x as x tends to a is equal to plus or minus infinity. Okay, so we require one of these two conditions here. And provided that the limit of f of x over g of x as x tends to a exists, then in that case, the limit of f of x over g of x as x tends to a is equal to the limit of f prime of x over g prime of x as x tends to a. Okay, so this result here then, this is L'Hopital's rule. Now in some cases, the limit of the derivatives is also indeterminate. So if this is the case here, then don't panic, we just simply apply L'Hopital's rule again. And it is worth noting that we can apply L'Hopital's rule repeatedly, given that the conditions are met at each stage, and that the numerator and the denominator can be differentiated the required number of times. So there we have it in terms of an introduction here to L'Hopital's rule. We don't need too much more than that. So I think the best way to demonstrate L'Hopital's rule here is to run through two practice questions. So let's begin then with question 1 here. So for question 1, we want to use L'Hopital's rule to evaluate the following limit. So we have the limit of x minus 3 over x squared minus 9 as x tends to 3. So to begin with here then, I'm going to let f of x be equal to my numerator. So f of x is equal to x minus 3. So f of x is equal to x minus 3. And then for g of x here, this will be equal to our denominator. So g of x is equal to x squared minus 9. Okay. Now, before we can apply L'Hopital's rule here, what we need to check is whether we have an indeterminate form. Okay. So to evaluate this here then, what we do is we take this value here that x tends to, so x tends to 3, and we substitute 3 then into these two functions of f and g. So in that case then, we get f of 3 here. So f of 3 is equal to, so that's 3 minus 3, which is just 0, right? So 3 minus 3, which is 0. And we do the same here then with this function g. So we get g of 3 is equal to, so we get 3 squared minus 9, which again here is just 0. Okay, looks a little bit like a 1. Let me just redo that just so it doesn't cause confusion. It's not 3 to the 1, it's 3 squared. So let me just redo that. So 3 squared there. Okay. So in this case here then, what we get is we get 0 over 0. And you should recognize here that 0 over 0 is an indeterminate form. Okay. So therefore we have an indeterminate form. So indeterminate form here. And what that means then is we can now apply L'Hopital's rule. Okay. So what that means is we need to differentiate this function f and this function g here with respect to x. So don't forget we differentiate these separately rather than applying the quotient rule. Okay, a common mistake here is to apply the quotient rule. Not correct, we differentiate f and g separately here. So in that case then, let's keep it in the center here. So f prime of x here. So f prime of x. That would simply be 1, right? We get 1 there for f prime of x. Doing the same here then for this function g. So this is g prime of x then. That would give us 2x, right? So we just get 2x there, like so. Now at this point here, right, I can see straight away that this will not be an indeterminate form. Okay. So what that means then is we can now actually evaluate the limit. So in that case then, so therefore the limit of the original quotient, so the limit of x minus 3 all over x squared minus 9 as x tends to 3 is equal to the limit, again as x tends to 3, of this expression here then, so f prime of x over g prime of x. So I get 1 over 2x, okay? And now to evaluate this limit here, right, it's not quite mathematically sound to say this, but we basically just substitute in this value of x here, right? So we get 1 over 2 times 3, which gives us 1 over 6 there. And there we have it. So this here then is the value of this limit. And that gives us the solution there to question 1. So moving on to the very last question here then, question 2, where again, all we want to do is use L'Hopital's rule to evaluate the following limit. So we have the limit of x squared all over 1 minus cos x as x tends to 0. And again, all we're going to do here is start by letting f of x be equal to our numerator. So in that case then, f of x is equal to x squared. And then for g of x here, again, g of x is just equal to our denominator. So in that case then, g of x here is equal to 1 minus cos x. So we get 1 minus cos x there. Now again, before we can apply L'Hopital's rule here, what we need to check is whether we have an indeterminate form. So let's take this value here then, that x tends to. In this case here, x tends to 0, and we substitute that into these two functions of f and g. So f of 0 here, that's 0 squared, which is just 0. And then for g of 0 here, that's 1 minus cos of 0. Or cos of 0 is 1, so we get 1 minus 1, which is 0. So what we've got here then is 0 over 0. And you should recognize here then that 0 over 0 is an indeterminate form. Okay, so let's just note that here then. So we have an indeterminate form. Indeterminate form. And in that case then, we can now apply L'Hopital's rule. So what we need then is f prime of x and g prime of x. So f prime of x here, nice and straightforward, right? We get 2x there. And then for g prime of x here, again, nice and straightforward, right? We simply get sine x here. Okay. Now, what I should check for here then is whether, again, we have an indeterminate form, which my suspicion here is that we do have an indeterminate form. So, again, we take this value here of x equals 0 and substitute that into f prime and g prime here. So we get f prime of 0. So f prime of 0 here is 2 times 0, which is just 0, right? And then for g prime of 0 here, I get sine of 0, which again is just 0. Okay. In that case then, again, we have 0 over 0, which again is just an indeterminate form. Indeterminate form. And again, what that means here is we now have to use L'Hopital's rule again. So this question here is an example where we have to use L'Hopital's rule more than one time, right? So what I need now is f prime prime of x. That's the second derivative here for the function f with respect to x. And also the same here then for the function g. So I need g prime prime of x to basically evaluate this limit here. Okay. So for f prime prime of x, nice and straightforward here. That's simply 2. Now for g prime prime of x here, that would give us cos x, right? So we get cos x there for g prime prime of x. We get cos x. Now, what I can see here then straight away is because we have this constant here, this form will not be indeterminate, right? So we can now actually evaluate this limit here. So by L'Hopital's rule then, what I can see here is the limit as x tends to 0 of the original quotient here then, so x squared all over 1 minus cos x is equal to the limit as x tends to 0 of f prime of x over g prime of x. We get 2x over sine x. So 2x over sine x there. And this here then is equal to the limit as x tends to 0 here of f prime prime of x over g prime prime of x. Okay, so that's 2 over cos x here. 2 over cos x here. Well, in this case then, what is cos of 0? So cos of 0 is 1. So I get 2 over 1 then, which is simply 2. Okay, so the value of this limit here then is 2 once we apply L'Hopital's rule. Okay, so hopefully this solution here does make sense. And like I said, this example here, or this question, is an example where we do need to use L'Hopital's rule more than one time. Okay, but there we have it, right? This here then is the solution to the very last question here, question 2. And that brings us to the end then of this video here on L'Hopital's rule.